would kill me if I said that. Just relax. It's fine, Mom.
What? Wait,
You're good.
stop.
That wouldn't go over well?
Oh, probably not. Yeah. I was like, Mom, just calm down. Oh, God. That's how you just,
To be
I
honest, it probably would.
All right, so let's see what we got here. University's trying to determine what price to charge tickets to football games. At a price of $24 per ticket, attendance averages 40,000 per game. Every decrease of $4 adds 10,000 people to the average number. Every person at the game spends an average of $6 on concessions. What price per ticket should be charged in order to maximize revenue? How many people will attend at that price? Okay, so, all right, so we've got then the ultimate equation here is going to be we're trying to maximize revenue, right? So what's revenue going to be?
price.
So it's going to be price, which
Price
is
minus
what do we call that? What do they call it? P?
Sure.
They don't even say. We'll call it P.
They don't really
Yeah,
look at it.
So XP, right? If X is the number of people.
Yeah. Okay.
Okay. Plus
X can
6X, right?
Okay.
We good? But we need to know what P is. We need to know what the price is, right? And that's called the demand function, by the way. It's called the demand function in economics. When you set the price based on what its impact is going to be on the number of people purchasing something. It's the demand function. And so to find the demand function, we're going to want to set up a function that helps us pick that defines P in terms of X, right? So what's that going to be? Let's think about this in terms of a graph. If we graph price as a function of X, what data points do we have? We'll assume it's linear. That's why I think really this question should say assume it's linear. So at a price of $24 per ticket, we get 40,000 people. So there's a data point that's going to look like 40,000, comma 24, right? And it says every decrease of $4 adds 10,000 people, right? So then that means that we're going to have some other data point out here that's going to have, so that's that data point. Some other data point that's going to have more people, but a smaller price.
Yeah.
So some data point down here, we'll just exaggerate this a little bit. So that's going to be 50,000 people for a ticket price of 20. Okay? Make sense? And so that's just going to give us a line. And we just need to know what the equation of that line is, right? So what do we get here? What's the slope going to be? We're going to rise by -4 and run by 10,000, right? So our slope then is what, 1 over 2,500 negative 1/2500th, right? And we've got to, let's just use one of these points. How about this guy to find out what B is, right? So then we end up with P equals MX plus
We did it
B.
the other way. We did like 10,000 over 4.
Yeah, you can do that. That's fine. I think this is better though because P ends up being, because you're going to have to substitute for P, right?
Yeah.
See what I'm saying? And so that's like a Y then. You see what I'm getting at? So then you end up with this function right here, P equals MX plus B, and I can just substitute for P. I did think about that. I mean, if you did it the other way, then you'd have
Well,
X equals.
they still did like, they just, for the slope, they just, I think.
They had a split. They had
Yeah,
P on
they
this
did,
axis and X on that axis.
Yeah.
The only disadvantage of that is then you would have gotten X equals MP plus B.
Yeah.
And so you'd have to solve for P at the end in terms of X when you plug it in, right?
So you just notice these things before you start.
I think about that stuff a little bit, yeah. Well, I mean, and here's, that meant, and I know I'm gonna have to make a substitution for P, right?
Yeah.
So it'd be nice, I mean, I'm just thinking, when I write my substitution equation, wouldn't it be nice to have P equals so I can make my substitution, right? I mean, what they did would work, but you see this is probably a little better.
Yeah, well, I think it was like 10,000 divided by like three and then X, and then plus like 40,000, which would be.
Right, RB is gonna
So
be,
that would just be P. That would always be P, right?
right, RP is gonna be a little different. RP is gonna be a price instead of a, right? But then when they did that, they ended up having to solve for P, didn't they? In terms of X. Right, because they've got to make that substitution.
Yeah.
They could have done that, and that's fine, it would work, but it's just a little, to me, that's a little backwards. It's not really the best approach, because I want to come up with P equals some function of X so I can plug it right in, rather than having to solve for P in terms of getting some expression X equals MP plus B, and then having to isolate P. It's not like it's hard algebra, but it's algebra, right? Okay, so then we could plug in, so we know that P equals so there's my function. I can plug in, I'll just do this. We can plug in values for M and for P and for X, right, to solve for B. So we would get 20 equals negative 1/2500th X, which is the same thing as negative 50,000 over 2,500. So let's cross a couple zeros off. 500 over 25 is 20. Right? So this is plus B. Right? Everybody with me? That just works out to be a negative 20, I think. Yeah, it does, doesn't it? Yeah. So then that gives us 20 equals negative 20 plus B. So B equals 40, right? And so if I plug both those things back in there, then I'm just going to get P of X equals negative X over 2,500 plus 40, right? And I can just feed that right back up in there, okay? And so that's going to give me, if I do that, what am I going to get? So I'm going to get R of X equals X times this, right? So that would just be 40, let's put the 40 first. So that's going to be a 40x minus x squared over 2,500 plus 6x. Okay, we good? Can I scroll down? Tell me when you guys are ready. Okay, so now we've got revenue by combined like terms as a pretty simple function of X. Right? What's my domain going to be? X is the number of people, right? So zero to infinity, right? There's really no limit, right? Okay, we'll just do calculus. So what's R prime?
X.
Okay, I get 46 from the first one, right? 46 minus x over 1250, right? And my second derivative is going to be negative, isn't it? Right? Okay. So then if we find the zero of this, R prime equals 0 when x equals 46 times 1250. Do we agree? Times. So I'm going to set that equal, right? Okay, and then that's gonna be, so that's gonna be the value of X that maximizes revenue, right? And so that's what they're asking for first, I think, isn't it? They want price, okay, actually, we answered the second one first. How many people will attend at that price? That many, right? If I wanna know what the price would be corresponding to that attendance, where do I go? Yeah, right there, right? Okay. That's a pretty common problem, to see something like that. You'll see that in college. They'll give you, it may not be that exact problem.
So like for that one, do we need the table?
I mean,
Or is it just?
I don't know if you really, I mean,
Kinda when it's rational.
you don't really need it. It's just so easy to do. I would always do it just because it's so quick. I mean, your table, it's just, you're scratching out really just one number with a 0 and a negative shows you that it's a maximum, right? And then that's a good way to defend your answer. Okay, questions on that one? Does that make sense? Let's have a little look at the second one, how about? Unless we can at least just talk about it a little bit. Oh, this is a good one. Yeah, I like this. So this one, I think we'll just draw the picture. You guys can take it from there. So a right triangle whose hypotenuse is the square root of 17 is revolved about one of its legs to generate a right circular cone. Find the radius, height, and volume of the cone of greatest volume that can be made this way. So you get what they're doing? So we're going to take something like, let's go ahead and situate this on the XY plane, how about? Right? And so they're just saying if I know that the hypotenuse is the square root of 17, and we're just going to spin that around one of its legs to create a cone. Right, so then this is going to end up looking like.
I made like halfway through and started plugging his numbers.
What happened?
I was like following along with my numbers and I made it like halfway and then I started plugging in your numbers.
Oh. Oh. Oh, man. So you guys see that's a cross section to our cone, but really this cone is going to look like that. Right? So what are we going to say?
Oh, okay, so,
What's the volume of a right circular cone?
pi.
Yeah, good. Right, it's a cylinder divided by 3.
Right.
So volume
Oh.
equals pi r
I don't just
squared
memorize.
h. Okay.
Yeah, just
So-
divide by 3.
So yeah, so what are our variables here then? We're calling this r and that's h. Okay.
Oh, yeah.
Yeah.
Does H need to be divided by 3?
Oh, I need to divide the whole thing by 3, don't I? Yep, there we go. Okay, so I've got how many variables in my 2? So what's going to be my equation of constraint?
Oh, something relating raised, right?
Yeah. Well, how about that?
Yep, that.
There you go.
Right. Got it right there.
Okay. So really what I could, now, let's be smart about this. In my equation, kind of look ahead here for a second. In my equation of constraint, which variable am I going to substitute?
H.
I would say, because we'd rather not,
Less squared.
right, exactly. So what's this gonna give, what does the Pythagorean theorem give us here? Equals, okay,
Or so.
pretty clear, we want to substitute probably for r squared then, don't we? Right, you see that? Right, otherwise, we're gonna get radicals in there, and why would we mess up, we don't wanna get radicals in there. Those are hard. That makes the calculus more complicated, but if I can write this in terms of, look what this is gonna be, I'm just gonna end up with a polynomial in terms of age, right? Okay? Stuff like that makes a difference too, that makes it big, it's easy, anybody can make a mistake when you're doing a hard derivative. Right, that's just human nature. People are going to make mistakes, so make it as easy as you can.
Equals whatever minus h squared.
17 minus h squared, right. See, that's a lot better. If I solve for h, I'm going to get h equals the square root of 17 minus r squared. Well, I don't want to do that,
Yeah.
right?
Okay.
Okay. So I guess let's go ahead and write the primary equation. And
Is
then,
it better to have the 3 over by the pi so then that's just a constant staying?
yeah, then you can just pull it out front, sure, yeah. So r squared equals 17 minus h squared. Okay, plug that in and get v of h equals pi thirds times r squared times, oops, sorry. Okay, what's my domain gonna be for h? 0 to square root of 17. Yeah, everybody see that? Okay, and so then when I differentiate, would I just leave it like that to differentiate? No, that would be product rule, right? We don't want to do product rule. Distribute the h, pi thirds you just leave out front anyway. And then you're just simplify, then you're differentiating a really simple
So like when you
polynomial.
differentiate it, do you leave the pi thirds or constant so it's 0?
Remember when we differentiate, if we've got a constant out in front of the function, we just leave the constant out there. Right.
Okay.